Welcome to Nordson ASYMTEK here at IPC Apex Expo. I'm delighted to be joined by Sonia Aldrich. She's a product manager for a new product called Vortik. Welcome, Sonia.
Thank you for having us. This is the Vortik Progressive Cavity Pump.
Right, Vortik Progressive Cavity Pump. So I think the title pretty much gives away what it is.
Exactly.
But it's a very unique new valve and cavity pump for the Nordson stable. Explain to me a little bit about the history, the development of it, and then we'll move on to the applications.
Okay, sure. So we realized that our customers were looking for higher volumetric accuracy in their applications, and one way to do that is by progressive cavity pump. The rotor and stator have a complete seal, so that enables us to get very high volumetric accuracies, dispense very low viscosity materials and also very large viscosity materials. So it gives us a good range. So because of that, we came up with we're introducing a new product, and we're actually introducing 3 families. VPS for small volumes. We're talking about mobile MEMS devices, the smallest actually in the market. And then we're moving on to VPM, which is a medium volume, VPG, which is larger volume for automotive and large encapsulation.
Right. So it's a case of using the same technology but putting it into 3 family groups for depending on the size and the application it's going into.
That's exactly right. Okay. Yes.
So looking at this progressive cavity pump and the way it works, you mentioned briefly the rotor and the stator. The rotor is a metal based product inside a rubber based stator. Explain a little bit why that works.
Yeah, right. So basically the rotor inside the stator is slightly larger than the stator, and the reason for that is because you want to form a perfect seal. That perfect seal allows you to be able to have high volumetric accuracy. It doesn't matter if you have variations in temperature in the production floor. You know, sometimes it gets cooler in the morning and warmer in the afternoon. Those changes can actually affect the viscosity of the material, and in some traditional dispensing, that could affect the output. With progressive cavity pump, you don't have that issue because it's perfectly sealed, so regardless of those changes, you're only dispensing the amount of rotation that you move the pump.
Right. So you could really pump any viscosity of material, you know, even down to water.
Absolutely. So water, because it's sealed, again, there's no dripping. Water-like materials should be very good with this, all the way up to paste-like materials.
Very versatile machine. So you seem to have 2 versions of it here too. I see you've got a 2-component version here, and you've got a single component version here. Can you explain how both of these work?
Absolutely. So the single pump is basically for traditional 1-component materials. Materials that are frozen, you take them out and you dispense. Basically they're pre-mixed, so you're dispensing it on 1 component. The nice thing about the 2-component materials is that these materials have long shelf lives. So as long as they're not being mixed, they have a very long shelf life. So a huge benefit of having those 2 materials separated is that you can have very large amounts of material coming into the pump, and you will not get a reaction until you start mixing them. Okay, so that in effect actually allows you to have longer production runs without any cleaning in between, and that's really where the main benefit of having this type of pump comes into play. The other nice thing about a rotation progressive cavity pump is that you're able to fine-tune the ratio. You know, if you have a 2-to-1, that's easy, right? But if you have a 2 to 1.27, then you're able to do that with the software just by adjusting the RPM. Okay, we automatically do that in our software as well. So I'm really excited about all this.
I can see that in your voice. So you know, you literally just control the speed, the RPM, as you say, of the rotor, and that controls the volumetric mix that you're putting together. Now, one of the things historically that used to be a problem with these types of valves was the number of moving parts. This seems to have very, very few moving parts and an easy part to clean. Can you demonstrate to our viewers how that works?
Absolutely. It's probably my favorite part. So here we're going to show you how we change from a production mode to night mode to calibration mode. So here we're starting off with a production mode. You lift up the lever. This completely comes off. You also unscrew the sleeve. Now you remove the static mixer. The static mixer gets tossed out for the end of the day. Now you're looking at only cleaning the wedge manifold, which is pretty simple with 2 holes that you need to clean. After you're done with that, you can set it up for night mode, which allows you to block the fluid ports for the end of the night, and that's keeping the material separate. The next morning when you come in, you also release the lever again, and you can go straight into calibration mode with this. So here you're calibrating part A, you're calibrating part B, and you use the same mechanism and simplicity to be able to do the calibration. After the calibration is done, you're ready to go back to your production mode, which is the static mixer, manifold, and sleeve. And there you have it.
Gosh, I think you should win some design awards for this.
Thank you.
I just love the simplicity of it. So, just to recap, it's called the Vortik Progressive Cavity Pump, and that's the latest product there available from Nordson ASYMTEK.
Yes, thank you.
Thank you.
I appreciate it.